Hello everyone and welcome to Rebelway. In this video, we're going to talk extensively about water rendering using Houdini and Karma. We have a few different examples that we're going to start with, going from easy all the way to a complex example that includes ocean, white water, foam. And we're going to cover a variety of rendering features and topic and things that you have to make sure that they are there to get the final result that you need. So let's get started. So let's talk about what we're going to cover today in more details. We're going to start with ocean rendering, which is the most common water-related topic that you have to do. And this is a test render using Karma and Houdini. And we're not going to be reinventing the wheel in this case. We're going to try to replicate Karma workflows presented by side effects and try to get those same workflows in Karma. This is going to be we can use the shelf. We can rely on the shelf tool to get us going with the initial node graph and setup and shaders, and then try to get the same result with Karma. So the first thing is going to be ocean rendering. We're going to talk about that. Then we have a water sim, and this one is just a flat tank with a box going through it and interacting with the water. So we have the water mesh. We have the water volume, which you see here. This is a volume surface rendered underneath. We generally don't see this, but for illustration purposes, I kept it visible. It's something that you only see in reflection and refraction. Then we have the white water here, which is rasterized at volume and rendered as volume in the final in Karma. I'm going to talk about that. The last example combines all of this. It combines ocean rendering as well as sim and the volume information under the ocean, as well as white water. We're also going to talk extensively about how to render white water using particles, using as volumes as particle, and as well as rendering them as points, but treat them as volume. So we're going to cover all these cases, and this can apply to many other effects as well that you may be doing. Right, what else? And then we have, we're going to talk about custom AOVs, how to set up all the necessary passes so you can have greater controls in comp. We're going to talk about a Cryptomatte setup, as well as the final render settings, which is talked about more extensively in previous videos. This is not a beginner tutorial by any means. It's going to dive straight into Houdini and we're going to start covering advanced topics. We're not going to be building the simulation here, but we're going to rely on the shelf tool to get the initial workflow. And I highly recommend watching this after you check out the Karma arrow scene rendering. That will give you the basics of rendering with Karma. And then the second one is the interior museum, which will cover render settings. This one is built on top of that. So if you're completely new to this, I highly recommend checking the other videos. All right, let's get started. So what is the requirements we have to solve to be able to render water efficiently and ocean in Houdini and or Karma? Well, we have a few things that we need in general. We have, let's say, a mesh that we deform to be ocean. We then have a water sim on top of this, so we can take a segment off of this and sim that. So we have a toy here, and this is where the simulation part is going to be. Okay, we take that, we put it through the flip solver, and then we combine the result back with a grid, with a mesh. So we have, this is the surface, we have the water sim here, and then we sim this part and then combine it and deform everything with the ocean spectrum. That's what the node in Houdini does. But that's not all. So we end up with a surface, which is a geometry of the sim. And on top of that, we need to create something else. To get that nice volumetric look underneath the surface, we have to make a copy of this mesh. I'll try to do that. So I'm going to copy this. Let's say that's our mesh. And what we need to do is we need to make a copy of the same mesh and extrude it and give it thickness. Now this new mesh is just a box. It's just the same sim, but extruded. So it has thickness. This will be rendered as volume. But we don't want to convert this into an actual volume. We just want to pass the full mesh to Karma or Metro or Arnold, and then ask the render to treat it as a volume. So that's the first thing. We need to learn how to render a solid geometry as a volume. Okay. Then we have the actual mesh, which is very simple to render. So this will have transparency and reflection. And if we look through this, sorry, I'm using the mice here. If we look through the water, we should see reflection, refraction, as well as the volume underneath it. So we can color that volume, give it the bluish tint that we generally see in rivers or ocean. And in this case here, I made it visible, and that's the volume. You can see how it's extruded. And it's made of a copy of the mesh, extruded down, and that's the workflow that is in Houdini by default. That's what we do in general. Then we have the whitewater, which is a particle sim. And this particle can either be rendered as points, you can render them as disks, and or you can rasterize, convert those points into a volume and render them as volume. The conversion, the rasterization process, when I say rasterize, meaning we do it in Houdini SOP. So we take the sim, convert it, and save it into disk as a volume. That's one way. The other way is to actually render the points, the spheres, at render time as volume. Same way we treat this, treat it as a volume, we convert or ask the render to treat the mesh as a volume. So we're going to cover all of these techniques. And then the displacement, of course, which is taking grid and displacing it with an ocean spectrum. So let's start with the ocean example. I'm going to use the shelf tool to create an ocean. And this is what the shelf will create initially. We have an ocean surface and we have an ocean interior. If I dive inside this, you see it's only displaying the a null here, so the result is not visible, but it's actually a copy of the mesh being extruded down. So it's the original mesh. Let me hide everything else. It's the original mesh, and then that gets extruded, and this going to be displaced at render time. So when we save the ocean deformation or the spectra file and apply that displacement to this box, everything will line up. So let's hide this and dive inside. All we have to do is the ocean spectra. So this is the file that the shader need. Now, along with this, Houdini and SideFX, they have pre-built shaders. These are very basic shaders that we can find in the gallery. Everything here, we have a basic liquid, ocean surface, and ocean volume. And let's start with the ocean surface first. So if I go to the material tab, material context, we have an ocean surface node, and it's reading the displacement or the spectrum file. That's where the file is. Then we have an ocean volume, and if I dive inside, you will see that it's an actual volume shader. And this gets attached to the solid geometry. You cannot attach this. It won't work with a surface. It has to, the geometry needs to be closed, watertight mesh. And this is a volume shader attached to that along with the displacement. So when I said the box is going to be displaced at render time, this is where the displacement is going to be applied. And then there is a setting in the geometry node to treat this as a volume. So if I remember this correctly, oh, sorry, it's just in the shader. So we don't have to do anything here. We just have to assign the shader, and it's going to work fine. In Karma, it's going to be done differently. Now, all these shaders are created in Matte. We can still rely on all of this, all these shaders in the stage context or in Karma. So everything is supported, which is awesome. And that's how we're going to save time. So what I'm going to do is I have a pre-built scene. And this first example is going to be basically importing the ocean surface and then importing the ocean box, which is this one. You see it has thickness. Let me change it to flat shaded. And now we're in stage and we're looking through the viewport of USD. We're not in Houdini. It says Houdini, but we're in the stage context. Sorry. Okay, so this is our ocean setup, and this is the final result of rendering that. And let's take a look. What we have here is we have a material node, and it's referencing the matte shaders. So I use the shelf tool to create the ocean, same as we did here. So you have an ocean surface and an ocean volume, and that's what's being attached to the surface in Karma. So if I go back to the stage, you will see that the ocean surface is pointing to, the material is being assigned to the ocean surface, and then the volume is being assigned to the ocean volume surface. Now, to treat this object as a volume, to tell Karma that you have to treat it as a volume, we create a render geometry setting node, then go under Karma, tick on set or create, and enable this. And then inside the uniform volume, we notice that this setting has to match the density of the volume. So what we do is we link the density from the shader, which is here. Let me find it. Sorry, this one. So we copy this cloud density value and link it inside the ocean surface. This way, we're not going to have any artifacts. And that's it. We use the shelf tool, assign those two, import the geometry, and make sure the spectra file is saved to disk. And now if I hit render, which I have already done, this is the result that will happen. Now let me do that here. And let me switch to the viewport. So it's going to take a second. It's going to take a couple of seconds for Karma to dice the geometry and give us the final result. But it's going to do it here. So let's see. Why is it not loading the spectra file? Let me restart it. It should displace the geometry. I'm not sure why it didn't do that. Yeah, this is the same scene. I just hit render, and this is the final result. Now, there's one more while this is going. I'm not sure what's happening, but this is the result that we're going to get once you guys receive the scene. And there's one more option. I did 2 tests. Yeah, it's working fine. I did 2 tests here, and you can see there's a difference in quality, mainly with the details of the displacement. So if I go back and forth, obviously we need more samples, but the second one has much more details. And this is due to a setting called dicing quality. And the default in Mantra, if I select the ocean surface and go under dicing, the default in Mantra is 1 and dicing flatness 0.05. Now to get the same result and match Karma with Mantra, you have to create a render geometry setting node and scroll all the way, and you will find this. The default is not the same. So if I middle click here, the default is set to 0.5, which is more forgiving. So this is the default setting. And then if we change that to 1, we get higher quality dicing and capture more details. This will be on par with Mantra ocean rendering. So that's pretty much it. You have the grid, you have the ocean surface, the ocean volume, and you save the spectra file and assign the shaders, and everything looks good. And then we're going to talk more about the volume under the surface in detail in the second water simulation example. Okay, so let's talk about simulation itself. This example was created using the flat tank shelf tool. We just put a box going through it, and it's creating the water ripples as well as the white water. Now underneath this, there's a volume surface, and then we have the mesh of the water simulation as well as the white water. And this is done using the flat tank. So if you click on the flat tank shelf and hit enter on the viewport, you will get the initial setup. Now what I'm interested in when you do this, you get 2 shaders. And this is what we can use. So a basic liquid shader and a uniform volume. This is pretty much the same one as we had it before. And we don't need the displacement. We're not going to use any displacement. So it's simply a volume shader that we can use. So let's take a look at the scene. And I'm going to keep it simple. So we're done with the ocean for now. And this is what I have inside of stage. And I will show the Houdini file in a second. Let me switch to the viewport. So we have the water mesh, and this is the result from the sim. So let's take a look at that. And this is one way of importing data inside of Stage. So you can have them imported in Houdini and then reference them from SOPs. You can cast them to disk as a geo file and load them. You can you can cast them as USD files and load them. It's totally up to you. So here I have the fluid sim. And what I'm doing is I'm reading the water, the white water. This is points. I'm reading in the water surface. This is the final mesh. You can see it's flat. There's nothing underneath it. And then we have the version of this that we're going to render as volume. So it is pretty much the same. If I template this, you see they line up quite well. And this one is watertight, so it has thickness. And this one is going to be rendered as volume and placed underneath the water. I'll show this again. This is the water mesh, and this is the water mesh that's going to be rendered as volume. And then we have the particles. So with the particles, we can do a few things. We can render them as points, we can render them as disks, and or we can rasterize them in Houdini and render them as volume, and or we can render them directly as volume, treat them as volume at render time. So here I have the points, and then I'm using some preview based on velocity to get this nice coloration. And here we have a conversion into volume. So the rasterization, this is the default workflow. And I'm also computing a gradient for this. So the gradient is going to be like a normal field, and we can compute a specular component on this volume, and I will show that. So that's one way of rendering it with the rasterization. We can compute a gradient field and use it to generate normal. We can also render these points as disks with no orientation or random orientation, and or we can render them as disks with orientation. And the best way to sample or get the correct orientation is to sample the surface field, which is an SDF that comes with the sim. So when you cache the water sim itself, it has points as well as a surface field and a val field. The surface field is a gradient basically, and it contains information about the surface orientation or the surface normal. So here I have the points, they don't have normals. And then after this, we're simply sampling the gradient and giving them a normal. And this way we can render them as disks with n. And I'll explain this once we get to the section where we need the where we're going to look more into particle rendering. Okay, so that's the normal being displayed in colors. Okay, let's go back to Stage. And here we have the mesh, just SOP import, referencing it. And then we have the box, or cube. And then we have the volume, the water mesh, to be treated as a volume. And this is the render setting, render geometry setting turned on, and the thickness or the density is linked to the uniform volume depth. And then we have the option to make this visible at render time or not. And I'm going to disable it for now. I'll show this again later. And then we have the particles being rendered as volume. And it's being referenced from SOPs. And then to turn on motion blur, let's go to Karma now. To enable velocity motion blur, you have to create a render geometry setting and apply it to the objects that it has this. In this case, it's all of them, all the geometry. And you can already see it here. If I go to the display setting, I can disable motion blur. And see, now it's super clean. And if I disable this, it means it's on, it's going to work. So we have to make sure that this is on, set or create, and then turn on motion blur and enable velocity. That's how you get your velocity, point velocity to render. Then we have the shader attachment, and this is a very basic shading. So we have a liquid, which is transparent and has reflection, that's been assigned to the mesh. We have a uniform volume assigned to this. And we have a volume shader assigned to the white water being rendered as volume. And I think that's pretty much it. Let me look through the camera. Yeah, so that's all we need. And I talked about having the volume not visible. In most cases, we don't want it to be visible. So what we do is we create a render geometry setting node and go under shading, create or set, and set the visibility to minus primary, meaning it's only visible to secondary rays, and that includes refraction, reflection, or any other indirect rays or secondary rays. So it's not visible to camera, but it's visible through the shader. And then for the coloration, you can see here the water mesh itself has some color variation. Now there's a gotcha here. And let me go to the fluid surface shader, which I believe is just a classic. Yeah, so it's a classic core shader. You can use any shader you want here. You can use any mantra related shaders like the principal core, whatever you like. But what we're doing right now is importing the vorticity attribute, which comes from the flip sim, as well as the velocity. And there's one gotcha, is that the velocity is not called V anymore. The reason for that, if I go to the mesh, the reason for this is that USD is going to unpack and import the data and prep it for its USD usage, right? It's not the same. So there's naming conventions that are different. And if I select the mesh, if you're having trouble figuring out why certain things don't work, you just select the mesh and look through the attributes. And they start with prim vars. You can see we have few. Vorticity is there, and then the V is getting renamed, or that's the naming convention of USD. It's called velocities. There's also a base color. We don't have it here, but if you need to access CD with an uppercase C and D, which is the default workflow, it's not called that anymore. It's called base color, and that it gets automatically renamed. So if you have shaders that rely on this, that needs to change to accommodate for that. Very, very important. So let's go back to the fluid surface and let me dive inside. So we're importing vorticity, velocity, remapping both of them, computing the length of velocity. So the higher speed parts have a different color. In this case, they look white. And let me do one more thing. I want to hide the white water so I can show this better. So you can see color variation on the water here. And that is based off the velocity and vorticity. And we're simply changing the color, adding a little bit of diffuse where there is faster moving points to just make it more interesting. Okay, the other thing, which is I think is very cool, is the gradient that we computed with the rasterized points. So when we imported the volume, the volume contains a gradient field, which is basically normal. And let's take a look at that shader, which is this one. No, this one. So it's a fluid uniform volume. Not this one, sorry. White water reflection. Nope. Where is it? Is this one. Yeah, so this is the shader that will give us the specular component. The way it works is we have a uniform volume or a volume shader, and then we also have a specular component, a PBR reflect, and it's reading the gradient, normalizing it, transforming it from world to camera. That's the shading space we need. And then that's being used as the normal. So that's how we're getting this nice highlight on the volume. And I'm going to go back and hide a few other things just to make this very visible. I'm going to hide the water, white water, and let's change this to black. Oh, it's fine. I can change it to black, but yeah, that's how we're getting this nice specular is because of that gradient and PBR spec. Again, we're going to provide all of this. It's all the default shader that comes with Houdini and the rasterization workflow, but that's how you get it to render. You have to make sure that you have a gradient field or compute the gradient of your volume and use that for the shading. All right, the next thing, I rendered all of this as a one sequence, one pass. But in most cases, we would want to split this into different passes. So you would have the water with the white water, and then the box is not visible. It would only be visible through reflection and refraction. And then you would have the box separate, being matted out by everything else. And the way to set mattes and in stage and visibility is using the render geometry node. So let me look through the camera. So what I want to do is I want to render two passes, one for the water with the box being visible through reflection and refraction, and then one for the box. So two passes. And to do that, we're going to use a render geometry node, select the volume, the surface, and the mesh volume, and set them to matte. Go under holdout, create or set this to matte. That's the box or the cube pass. The next thing is we want to make that cube invisible to primary rays. So create another render setting node, render geometry setting. We tell it only to apply and work on the cube, and then minus primary. So it's only visible to secondary rays, and that gets written to disk. And then if you overlay A over B, it's going to work and look perfectly fine. So that's all there is for water rendering. You have the ocean. You have the water mesh surface. You can use any shader you want. You just need refraction. It's available all the shaders pretty much. And then you have the underneath volume. You can use a uniform volume. Make sure the settings and the depth matches. And then if you want this to be visible or invisible, depending on your use case, you can use a render geometry node with the primary visibility turned off. And then if you want to render white water as volume, and with specular, that's how you do it. You compute the gradient on the SDF or on the volume. You cache that, and that's what gets used in the shader. And again, I think with the scene being provided, I will cache out one frame of each, so you can replicate this. You can use a shelf tool to create the basic shaders, but they're all pretty much the same. If you hit Alt G in Houdini, you've got basic liquid, ocean surface, and ocean volume. That's all what the shelf tool is utilizing pretty much. So let's talk about particle and white water rendering. We have 4 different ways, and I mentioned this already. We can render the points as points, spheres. We can render them as disks. We can render them as disk with orientation. We can render them as spheres and treat them as volume to get the volumetric look. Or we can rasterize them in Houdini and convert them into a volume and treat them as a volume. So there's 5 different ways. I'm going to show, we covered one of them already. I'm going to show three others. So let's take a look at this. I have the particles here. And again, there's few gotchas. So this is really what this is for, to cover all the necessary workflow issues that you may run into. So the first thing you want to do is you don't want to cache, you don't want to change the data. If let's say you didn't like the P scale here, you have to post-process it in the scene. And to do that in stage, without recaching, to do that, you put down a attribute wrangle node, and the P scale attribute is called widths. Okay, so what I'm doing right now is I'm simply changing that to something lower, in this case 0.005. So that's how you change the P scale of the points, and they're being rendered as spheres. To change that, you put down a render setting node, render geometry setting node, and then scroll down to a geometry, render points as, and you have a few options. You have disks, spheres, and oriented disks. If you change that to disk, that's what you get. You get disks. And let me take a look at the final result through the camera. And let's make sure we are on switch 0 and here on 0 as well. Okay, so this is our disks or points being rendered as disks and no normal. Let me turn off the motion blur. So under the settings, disable motion blur, and that's our disks. The next option is to render them as disks with normals, and this is how you. This is where you sample the normals from the SDF gradient or from the sim. Now by switching this, let me make sure you guys remember this. Let's go to the soft context. And this is where you do it. You load in the original sim, has a surface field, and then inside there's a volume gradient, and you sample the gradient from that. And currently it's being plugged into the color just so we can see it, but the important part is using it as normals. So we know what the orientation of the mesh is, and that's what the disks will have. And if I zoom in all the way, you can see they're nice disks. But the cool thing is now you can get specular component and get this to look very close to the surface. But it's not, it's just points. The next thing is to use them as points. Number 2. And with points, you can get them to be rendered as volume. So that's the main advantage here. And it really depends on the look that you're after. There's no right or wrong. You can choose whichever approach you want. And also this is applicable to other effects rendering. So if you're dealing with particles, this is how you work with them. So to render them as points, which is the default, you just set this to spheres. Okay, now with spheres, like I said, we can render them as surface or we can render them as volume. And to do that, we simply create a uniform volume render geometry setting and turn on uniform volume and make sure that we attach a volume shader as well as use a link this density to the volume shader density. And that's what this node is doing. It's attaching a volume shader. If I go there, this is the uniform volume. Nothing fancy here. So let's go back and let me switch this to 1. And you will see that this starts to look, well, it is a volume. But if you go close enough, you'll see that they are actually spheres, but they're being treated as volume. That's one way of rendering it. This is different than rasterizing it in Houdini, but this is one way of getting the volumetric look with points. And motion blur it works just fine. And all you have to do is make sure you set the turn on enable motion blur and tell it to use velocity to get the nice motion blur streaks. And let's switch this to, let's switch this one to 0. So we render it as a surface. And that's our particles being rendered with velocity motion blur. So that's all there is. Particle p-scale, this is how you do it. You can render them disks, oriented disk, spheres, and with spheres you have the ability to render them as volume. All right, now to the more advanced example, which combines ocean with flip sim as well as whitewater. And we put a ship here with textures. This was already shaded in Mantra, so we just copied the mesh and the shader and reassigned them here. There's nothing crazy going on. And then the sim has been done and displaced and saved to disk with all the information that we need. So let's take a look at what we have. So this is a more complex example. We're going to cover custom AOVs in Cryptomatte. That's why there is more things here. But we're going to go through it step by step, and I think everything is going to be clear. So we have two material nodes here just to keep things clean. Let me disable the rendering. So we have a ship shaders, and let me dive inside that. This is all just reading the specular texture, diffuse texture, and getting it assigned to the right meshes. And then we have an effects library or effects material library effects called, and it has very basic shaders, ocean surface and ocean surface volume. This is what you get by default. And then yeah, same thing here. And then we have a whitewater shader, which is a uniform volume. Okay, so for the data, we have a mesh. So this is the ocean surface, ocean grid, and with the flip sim combined with it. So we just have a single mesh, and we're going to apply the ocean displacement to all of this and get it to be displaced at render time. For the render settings, we're setting the dicing quality to 1. to increase the details on the mesh. Then we have the ocean, the fluid mesh, which is the same thing, simply extruded and being treated as volume. Same thing as before. Uniform volume, the depth. The string attribute, or this wrangle node, is creating a string attribute called myID, and it has a text called, or a value of fluid mesh, equal to a fluid mesh in this case. And this is for Cryptomatte. We're going to cover this later. Then we have the whitewater. It's points, and we're increasing the p scale here. Let's take a look in Karma, making them thicker, and then we're rendering them as volumes. So the points are being treated as volume. But there is a trick here. There's a gotcha. There's this edit point node, and if I disable that, everything will disappear. And you will spend a week trying to figure this out. Maybe not a week, but you'll spend some time trying to figure this problem. So the reason this is happening is when we import this data, let's see why it's not showing. So when we import this data from SOPs or from disk, or in this case, it's being read from disk using a geometry sequence, and this is another node. So the sim is cached in red. And this whitewater sim has an attribute. When you run whitewater sim, you get an attribute called density. And this attribute was conflicting with Karma and USD and the shader data, and it was making things invisible. So what we need to do is we need to delete that attribute. You need to delete the density attribute, unless you need it, obviously, for certain cases. But in this case, we don't need it. So to remove it, you select the data, click on the points, find it in the tree, and then find this density attribute. You can see it here. Right click, edit property, and this will add a node to override that value. And what I'm going to do is I'm going to click on this pen icon and set it to block. That's what this node is doing. It's blocking that density attribute, and that makes everything works. So it was setting, if I don't have this, it's setting the attribute density to something very low or 0. I needed to delete the density attribute. So that's how you do it. Then we have a string attribute. This is again for Cryptomatte. We have the rubber toy object with transformation. This is just being copied the same from SOPs. And then a string attribute as well. We have some cameras. You can import cameras from SOPs. You can create them here. And then the shaders, and everything gets combined along with the ship. And then we have the material assignment for the ship. So this is just assigning wood, ropes, whatever it's needed. And then the material, the effects material, is assigning the volume shader to the volume geometry, the ocean to the ocean, whitewater to the whitewater volume, or uniform volume, and then the rubber toy. And I believe Karma is trying to, it's rendering right now, and it's trying to dice the geometry. So it's taking a bit of time. And I'm going to try to change the camera. Maybe this is the one I used. No, the one I used to render is this one. So it's going to take a second. Let me switch it to camera 2. And it's going to just take a couple of seconds, because when you have displacement, Karma is going to dice the geometry and then display to you. And I really apologize if I switch between, if sometimes I make a mistake and say mantra and not realizing it. It's been very confusing to all of us, but yeah, this is the new workflow, and we're focusing on Karma. So I think that's really it for the shader. You have the water mesh, you have the water volume, the water mesh volume, and you have the whitewater particle points, whatever you want to render them as, and then the shader being assigned the liquid, the volume, uniform volume for the under the water mesh, and then the points, in this case, we're rendering them as volume as well. So that's the result. That's what I have here. Okay, so let's talk about custom AOVs and custom AOVs in the next video. So the last thing we're going to talk about is the AOVs and Cryptomatte. So here I have a render, and this is what we have. We have few Cryptomatte material AOVs, and this will allow us to pick and create masks in Nuke on the fly. Then we have the default utility, depth, N and P. We have more data for Cryptomatte, and then we have direct diffuse, direct reflect, emission, effects util. This is the custom AOV, and then we have a few other ones, and this is all the default. Now the effects util is a custom AOV, and it's storing the velocity and vorticity as red and green. So here I have two masks, and we can use this in comp to make color variation to the render if we wanted to. So let's talk about the default. Instead of using all of it and putting the AOVs in Karma node and losing that, we can just create a standard AOV. So if you're in production, they have a predefined list of names or things like that. You can create a template and have them be the standard. This is the nodes you plug in before you render, and all the AOVs are set up. So here, this is the standard AOVs. And what Igor did, he set up the file. He mapped all the names to Mantra. And this way it stays consistent with Nuke. You don't have to do this depending on where you what your project is, what you're doing. But basically, if you want to get the same naming for direct diffuse, direct reflect, and all of that, this node will help you with that. And it's basically enabling direct diffuse, indirect, direct reflect, and keeping the names consistent with Karma. And then we have few utilities AOVs, and this is the P and N. And we're using a node called render standard Karma standard render vars. You can have as many as you want. Okay. The next one is the albedo, and this is useful for denoising. So if you want that, you can just enable it. And then we have extra effects. This is for custom. They don't have to be separate, by the way. Like, you can use the same node. And to create a custom AOVs, you use a node called additional render vars. And then you hit the plus button and give it the name. This is all that matters. The name, how you want it to be named in the EXR, and where this data is coming from. Let's take a look at this effects util. It's in the effects. And then it's the mesh, displaced mesh. So we are changing the color of the diffuse of the water using velocity and vorticity, and we simply wanted to export this data as red and green. So using a float to vector, the red is going to go to vorticity, and the blue green is going to go to velocity, and then we export this as a color called effects util. That's how we create custom AOVs, same as Mantra before, and this is how you would declare an extra AOV in Karma for them. The next thing is the Cryptomatte. So we have two things. We can use this standard Cryptomatte, which will analyze the scene and use the object name and or object material to give you masks. This is the default. You don't have to do anything. You just set Cryptomatte object, Cryptomatte material name, and it will auto-define itself. And then if you want to create your own, let's say I like to group all the water separately, all the geometry, all the ships separately, and then the toy separately. You can go inside of stage and create these attribute wrangle nodes, and this is how you create a custom attribute, a custom string. So it's called my ID, and I'm just giving it a string value. And same here, it's called my ID, and it's called fluid mesh. So I'm going to combine all the fluid water related stuff, and then the white water separately, the toy separately, and the ship separately. So if I go in the Cryptomatte and I'm using a render var node, I think you can also use the standard, the additional render var, same thing. And here, all you have to do is tell it to be, use these strings. This is the default. Yeah, I think. Yeah, potentially you have to use this. I'm not sure why Igor used this one, but I believe this is the workflow. So you type in crypto prim ID. This cannot be changed. You have to name it this way. And then the source name is my ID. And under the settings, this is the options that you need to turn on. You have to tell it that this is a Cryptomatte, and this will create your own AOV, your own Cryptomatte mask based on that ID string that we've declared. And then the render settings here, I didn't do anything really. It's just the default. So pixel sample set to 32. And then the variance 1 to 8. Under advanced, I turned off the pixel oracle. And then the depth or the limit is 1 to 2. That's how the entire sequence was rendered. No AOVs. And like I showed before, this is the final result. And this is all the AOVs that we need. The Cryptomatte may work here, but generally it's not going to show as you would expect it in the viewer. It's more designed for comp stuff. And this is the Cryptomatte default based on the material. This is based on the object name, and this is based on our custom ID. I think this name can be anything you want, but the most important thing is that you have to tell it which string to look at, and then you have to toggle the Cryptomatte attribute option to make sure that this is treated as Cryptomatte, because it has to save data differently. And then all the other passes are there. All right, guys, I hope everyone liked this and found it useful. I think we've covered all the necessary steps to render ocean, water, white water, and everything that comes with it. Again, this is not a beginner tutorial. It's designed for existing Houdini users, and I hope that it will provide you enough guidance to transition workflow and being able to render your water effects using Karma. Overall, I think it's very, very promising. The render time are very reasonable, and I think it's faster than Mantra. I haven't done any one-to-one comparison, but so far we have been able to render all the effects and projects that we needed to do. And again, there's a lot of gotchas. There's a lot of things that needs R&D, and I'm hoping that with these videos we will save everyone's time and show how things needs to be used and done. All right, so everything should be included, and I think good for now. Talk to you soon, and bye-bye.